Let's hope this works out, because this would be a live demo, and as you know, the wireless is not so good. So maybe just turn off all your devices that we have some access. No, we have a backup for at least this talk. The next talk would be really a problem then. But yeah, let's start with machine learning. Maybe this helps us. As we said already at the beginning, no, not working with this one. This one is better. Artificial intelligence is a main topic for us. It's one of the hottest topics in the industry right now. And we are, of course, targeting this in our day-to-day thinking, and also in Pimcore in general, as we see a huge benefit in using machine learning technologies in Pimcore in nearly every area. And when I mean nearly every area, I really mean a lot of different use cases that we are faced in our day-to-day projects, in our day-to-day business, and I just have put a few of them out there. Like we have all topics with image. Here we say image classification, but it's also image detection, that we detect maybe unwanted content that is uploaded to our systems, these kind of things. So everything with image is a huge topic in terms of machine learning. The other huge topic or important use case is the product classification, or let's put it also a bit more in one more general aspect, in master data classification. So can be, of course, data objects that store anything, like products, like customers, like whatever is stored in structured way in Pimcore, and we can classify them and also, of course, detect them and all these kind of things. Then another big topic we faced regular are duplicate detection, again for images and videos, so any kind of digital assets, and also, of course, for structured data to make data duplicate detection, these kind of things. And one additional use case more in the data management part of Pimcore is data mining, where we're going to research for additional information that is stored somewhere in our data, since we have, of course, the master data in our systems and also transactional data, and when we can relate them with each other, we can mine for additional information, for additional things that we might notice. In the terms of the experience manager of Pimcore, there are also, of course, a lot of different use cases for machine learning. 3 of them I've put on the list here. Text generation, Dietmar mentioned it already, to generate texts with proper language, with proper grammar, based on structured attributes that are managed inside Pimcore. Then, of course, chatbots, which also, of course, include the topic of speech recognition, or at least text recognition, so text recognition, that we know what the user is typing or talking to us. And last but not least, recommendations of any kind, so I mean that product recommendations, search recommendations, content recommendations, any kind of these. And these use cases, all of them, and there are a couple of more, have one thing in common: they are completely different. Different in the terms of the approach they need, different in terms of the data they are working with, different in terms of the user group that's using it, different in the results that are providing us, and that leads us to the conclusion that machine learning is not machine learning, and it really depends on the use case, what you need, and just throwing in the buzzword machine learning into a project won't solve the challenges of this project. It's just, you need to use the right approach for your requirement, for your challenge that you are facing. And talking of these use cases, we actually detect somehow 3 types of machine learning applications. The first type, we call them general use cases, are use cases where it makes definitely sense to use public services to take advantage of crowd and cloud knowledge and intelligence, like image recognition, image tagging based on public classification systems, or also speech recognition, all these kind of things where it definitely makes sense to use huge swarm intelligence. Then the next use case is a bit more special in terms of what I want to achieve. We call them special use cases. These are classically, I want to classify to classification systems which are quite specific to my use case. And these are systems where I cannot use public services because I need to train a custom model for my use case. And then, at least I think, and we face them on a regular basis, there are also use cases to the third area where you don't need machine learning at all, and where a simple set of rules and classic algorithms do at least the equal good job or maybe even a better job with less complexity. So yeah, it's really just use machine learning when it really makes sense to use it and not just because it's cool or something like that. And yeah, for these three types of applications, there are a lot of different systems and services around. And I put a few of them to the slide. Actually, I put them on the slide which we used already in either some demo projects or in proof of concepts or also sometimes in live projects. Some of them you might already know. I guess Google Cloud Vision API, Amazon Recognition should be quite well known. TensorFlow was already mentioned today. Prediction.io is an engine for predictions, for recommendations. Dialogflow, maybe some of you already know that too. It's an engine for chatbots. Then we have TextEngine.io, which is an engine to generate texts based on structured data. And then, of course, we have the more basic tools like Python or R, which are more programming languages, especially for data mining, for statistical purposes, and these kind of things. And yeah, in the last couple of months, I already mentioned that we worked together with universities, we worked in-house and really tried to figure out how we can use all these available tools and services in a meaningful way and how we can utilize them with Pimcore. And well, long story short, we think that there are a lot of tools out there, and these tools do a great job for what they are built for, and therefore we don't want to restrict ourselves in terms of flexibility, in terms of the features. And yeah, in general, we don't want to reinvent the wheel, and this leads us to our approach that we are going to go with machine learning, which is, I said it already, a pragmatic approach where we don't want to reinvent the wheel. We really want to connect to existing tools and services, provide the best APIs, and keep all the flexibility for customization as we do it always with Pimcore, basically. And yeah, having said that, we also have prepared already a small proof of concept which should show you how we want to approach this. This proof of concept is available at GitHub and is one of the results of our research cooperations. It actually was created by Paul from the University of Applied Science in Hagenberg, which is in Austria. And yeah, this is the thing we're going to show you right now. So, Andy?
Thank you very much. Can you hear me? Yeah. Now I'm going to be a little bit more specific. So at Elements, at my company, one of our clients approached us and he told us, hey, I'm a big construction company. I'm working globally. I have construction sites all over the world. And within our projects, we collect a huge amount of photos. So those pictures, for example, from new innovative projects are all collected and sent to a central marketing team. And they spend a huge amount of time just to classify some of those images into categories so that those images can be used in various marketing channels, such as on the website or for presentation purposes. So the challenge that we had to approach was to reduce the manual effort and automate the classification process. And in this case, we faced the problem that that out-of-the-box solution such as Amazon Recognition or the Google API wouldn't do the job, as those categories are very domain-specific and also given by the customer. So that's why we evaluated various machine learning algorithms and trained the algorithms. And it turned out that the algorithm worked so well that we got curious and asked ourselves, well, is it possible to also apply the algorithm not only in this industry, but also in other domains, such as the automobile industry, let's say classifying cars and so on. And as a result, we created a Pimcore plugin, which Christian said is already available on GitHub. So it's also based off the new Pimcore demo version. And actually it works like this. You are uploading images as assets in Pimcore and using a specific amount of training data for each of the categories. And each of the images is pre-tagged in Pimcore. And afterwards, an algorithm can be trained based on the pre-classified images. And in the end, there is an integration in the Pimcore user interface that lets you automatically classify newly uploaded images. So I'm going to show you a short demonstration now. It was planned to do it live, but the network didn't work very well, so let's give it a chance. So, as you can see, or not see, one moment.
Dark is always good.
Perfect. So I hope you're familiar with this interface. As you can see, we have Pimcore assets in the left hand, and in car images we uploaded training data. And we uploaded images of old cars, and those are classified based on their brand name, and within each brand name based on their country of origin. So for example, this car, if I switch to the tags view, has been classified as coming from the United Kingdom. Another example is BMW, which is a German car. And here you can see it's pre-classified as a German car. So based on those images, those images were our training data. And we applied the training data on our algorithm so that the algorithm could learn. And then we made the algorithm available in the Pimcore user interface. And now it's possible to upload assets and use the machine learning algorithm to automatically detect the country of origin. So on the right-hand side there is a button which is used to call the algorithm in the background. So let's take a look at this one. This has been automatically classified as a car from the US, which is correct in the case. Now let's take another example. This one, this fancy car is from is a Citroën from France. Again, I go there. I just reset the result so that you can see that it actually works. I click on auto classification again. And hopefully this one is categorized as a French car. Let's take a third one. This time I'm going to use a car from the UK. Again, we execute the algorithm in the background. And again, it has been automatically classified as a UK car. So actually, the result turned out that the algorithm is very precise, and in almost 80 or 90% of the cases always predicted the result correctly. And Paul is now going to give you some technical details.
Thank you.
We made some screenshots in case the live demo didn't work out. But now, let's under the hood. Paul, please.
When I started my work, I tried to find existing and usable solutions. And the first two I took a look at were the Google Vision API and the Amazon Tagging API. But the problem is that I didn't see a way to easily adapt them to my needs. Thus, I looked further, and finally I found the retrain and a label script by Google utilizing TensorFlow. And actually, those two scripts were exactly what I hoped to find. They spared me a lot of work. Retraining comes from the fact that the script is using pre-trained networks. This means that the networks are pre-trained on huge image databases, which of them a variety exist, and they have a big pro, namely they spare lots of computational power and time, because the heavy lifting, namely the initial training, which can take weeks, is done on very suitable and potent hardware. And this also results in the fact that less original data is necessary, because you can't train a huge network from scratch with around 180 images. It won't work. But when using image databases, it can work quite well, as seen in the proof of concept. One of the cons of those is the licensing, not of the networks, but of the image databases. If you want to just pick a part of the image database, it can be hard to get access to, because most of them are for academic use only. And also, those image databases are not for every use case, because a pre-trained network, I worked with a network pre-trained on the ImageNet image database, and it consists of over 14 million images divided in nearly 22,000 categories. And yeah, as you can see, 22,000 categories are a little bit more than the 8 categories I really worked with. That means that it can introduce a lot of noise and maybe don't work quite well. I got these networks from the Tensor Hub, which is part of the TensorFlow website. It's a platform for hosting machine learning modules in all kinds of states. You can get no networks without any pre-training or pre-trained on different data sets. And a big positive aspect of those modules is that they have very advanced architectures. The network I worked with, achieved the best performance with, was the PNASnet, which stands for Progressive Neural Architecture Research. And actually this means that the network is, well, not the network itself, but while training, different architectures are tried progressively, and the best ones are picked, and which results in very good performance. But to feed images into a network, you have to pre-process it. I experimented and tried to grayscale the images, because I thought maybe for classifying building types, it's not, it doesn't matter which color the buildings do have. But this actually decreased the performance quite a lot. And after thinking a bit, this makes sense, because all of the images in the ImageNet, or nearly all of them, are colored. So you can of course not throw some grayscaled images into a network trained with 14 million colored images. Another problem is the resizing, because a network normally has a fixed amount of input neurons, which fits the resolution of the image. And the retrain script is pretty cool in that fact, because it actually moves the downscaling to the module you download. So every module can decide itself which resolution it needs, and then downscale it automatically. But how is retraining actually working? Well, it's rather easy. You just put a new layer of neurons corresponding to the categories you work with on the output side of the already pre-trained network. And this layer is called bottleneck layer in Google terms, because you can imagine that it actually reduces or combines the features taken out of the image database and combines them to the categories you want. This is a big advantage, and the advantage is that the complete network is only executed once and then cached. This means that only one layer is trained, which is very fast. The Inception v3 network I also worked with needs around 2 to 3 weeks to train from scratch. The retraining takes just 30 seconds, so quite a lot faster. After analyzing the script and finding out that it's really cool, I created an interface to Pimcore. The first problem I encountered was that the retrain script takes real files and folders as input parameters, whereas the images in Pimcore are tagged. And after getting the location of the images, I just symlinked them to the temporary training directories, which is really fast because no unnecessary copying or moving is done when symlinking. And after retraining, the network and the label files are simply stored in the file system by a name and version. The tagging then is also rather simple. It's more or less just a wrapper for the label script. You just have to get the image of the file again. Then you put it inside the label script. It puts out an array of confidence and the categories. And then you can just take the tag with the highest confidence and assign it with the Pimcore tagging command. And there you have it. You have your image tagged with a Pimcore tag by artificial intelligence. Thank you.
Pimcore. Own the digital world.